Hi everybody, thanks for watching my video. Today we're going to be talking about the Bohr model and we're going to do some practice problems of elements using the Bohr model. But first, before we start our practice problems, I want to talk about the periodic table. To do these problems, you are going to need to have a periodic table with you. And I'm going to start by explaining what these elements in each atom mean. So when you look at your periodic table, you know that each square is representative of an element. And they have a number at the top, which is called its atomic number. And what that tells you is the amount of protons that an element has. It also tells you the amount of electrons that an element has, as long as the atom is neutral. We also have the symbol, and that tells you what the element is. So you'll hear me referring to the proper name of elements, but you'll only see the symbol there. And I don't expect you to know which symbols go with which element, but you should be able to at least find the symbol on the periodic table. And the third component of the periodic table is the atomic mass number. And that tells you how much the atom weighs. And so what goes into an atom's weight are its protons and neutrons. So finally, I want to talk about electron shells. And all you need to know for that is that the first shell contains 2 electrons, the second shell contains 8 electrons, and the third also contains 8 electrons. And this is a maximum number of how many electrons each shell can hold. So the first shell, it could hold 1 electron, but it can't have 3. The second shell, it could have 5 electrons, but it can't have 9 or anything more than 8. And the same for the third shell. And so you notice that I also did this color coding system, and the electrons are represented by red dots. And so you're going to see me use that throughout my examples. Protons are colored green and neutrons are colored blue. So let's begin with our first example. Our first example is magnesium. And the first thing what you want to do when you're doing these problems is draw the nucleus, just a circle that has a little bit of space so you can write some information in there. And what I'm going to have you write in the nucleus is the number of protons and neutrons that magnesium has. And that makes sense that we call this circle a nucleus because protons and neutrons reside in the nucleus. So next we're going to look at our periodic table and figure out how many protons and neutrons magnesium has. Well, we know that the magnesium's atomic number is 12, and the atomic number tells you the number of protons an atom has. So we know that magnesium has 12 protons. Next, we have to figure out the number of neutrons that magnesium has. And to do that, we look at the atom's mass number, and that's 24. So I said earlier that an atom's mass is determined by the number of protons and neutrons that it has. So if we already know the number of protons, we can easily find out the number of neutrons just by subtracting 24 minus 12. And that'll give you 12 neutrons. So now that we've figured out the nucleus of magnesium, we need to start drawing the electron shells. Before we start drawing them, let's talk about how many electrons we need to include in this model. The way you figure that out is by looking at the atom's atomic number. And that's 12 right here. So we know that we need to somehow fit in 12 electrons to the Bohr model of magnesium. First thing you're going to do is draw the first shell, and that should be kind of close to the nucleus, but also a little bit far away. Make sure you have enough room on your paper to draw additional shells if you need. So I told you earlier that we can fit 2 electrons in the first shell. So we're going to go ahead and do that. Just put 2 electrons there. You can't fit any more than that, so don't try to do that. The next thing you're going to do is draw a second shell because we clearly don't have 12 electrons yet. We need 12, but we only have 2, so we're going to need to draw a second shell. Before we start drawing it, let's think about how many electrons could fit in the second shell. Well, I told you earlier that a maximum of 8 can fit in the second one. So if we put 8 in the second shell and we have 2 in the first, that means we're going to have 10. So we can go ahead and fill up the second shell. And you can check this by counting the number of dots and making sure it matches the atomic number. But this still doesn't get us to 12. We have 2, 4, 8, and 10. So we still need 2 more electrons. So that means we're going to need to draw a third shell. And we're going to need to put 2 electrons in it. So just put one at the top and one at the bottom. And when you are placing electrons, don't place them as far apart as you can. If they're in the same shell. Don't put like 8 electrons in the same shell next to each other. Make sure they're spread out. This is actually the completed model for magnesium. So you're done as long as you've included these components. The next example we're going to do is hydrogen. And we start off by drawing the nucleus and looking at the periodic table. The periodic table tells us that its atomic number is 1, meaning that it has 1 proton. So the periodic table also tells us that its atomic mass is 1. But I know it says 1.008, but that's still very, very close to 1. So we're going to consider it as just 1. Its atomic mass is 1, and it also has 1 proton. So that means that it has 0 neutrons. And I know this may seem a little bit weird, but hydrogen is the one element that does not have any neutrons in it. And you do need to indicate this, the number of neutrons, on your model. Even if it's 0, I need to know, and you can write neutrons equals 0, you can write n equals 0, or whatever, however you want to indicate that. It has to be written there some way. And next we are going to draw hydrogen's electrons. So we know from the atomic number that hydrogen has 1 electron. So we're going to start by drawing our first shell and placing 1 electron in it. And that is actually the completed model for hydrogen. Our next element we're going to look at is argon. And we're going to draw our nucleus and look at the periodic table. It says its atomic number is 18, so that means it has 18 protons. If we look at its atomic mass, we can find out the number of neutrons by subtracting 36 from 18, which gives us 18 neutrons. Now we're going to start off placing the electrons and drawing the first shell. Well, we know that we can put a maximum of 2 in the first shell, so we're going to do that. Next, we're going to draw our second shell and think about how many could be placed in this second shell. We know that we could have 8 max plus 2 is 10. That means we can fill up the second shell. So now we have 10 electrons, and we still need to have a total of 18, so that means we need 8 more. We're going to need to draw a third shell. If we need 8 more, and the third shell can hold a maximum of 8, we can just go ahead and fill the third shell. And this is the completed model of the Bohr, completed Bohr model of argon. Next, we're going to look at carbon. And we're going to start by drawing its nucleus and looking at the periodic table. We notice that its atomic number is 6, so that means it has 6 protons. And its mass number is 12, meaning we have to subtract 12 from 6 to give us 6 neutrons. You'll also notice that because its atomic number is 6, we need to represent 6 electrons in the electron shells. So our first shell is going to have 2 electrons. And we're going to draw our second shell, but not write the electrons yet. We're going to think about how many electrons we still need to put in the model. We have 2 so far, and we need to have 6. So that means we need 4 more. And even though the second shell can fit 8, we're only going to put 4 in the first shell. And this is how we're going to place the electrons. I know I told you earlier to make sure the electrons are as separated as possible, but this you still need to put them in pairs. Electrons bond in pairs, and this is why they need to be placed 2 and 2, like this. So if you do place them in other areas, you will get marked off. Make sure they are in pairs if they can be. The next example I have is aluminum. We're going to start by drawing our nucleus and looking at the periodic table. It tells us that its atomic number is 13, meaning that it has 13 protons. And when we subtract its mass number, 26, minus its atomic number, 13, we figure out that aluminum has 13 neutrons. Now that we've figured out the nucleus, we are going to start drawing the electron shells. Our first shell can fit 2 electrons, and our second shell can fit 8. So we're going to draw 8. Then we're going to think about how many electrons we have so far and how many we need. We have 8 in the second and 2 in the first, so that means we have 10, and we need 3 more. So we're going to draw a third shell, and we're going to place the electrons like this. Like I said, we need to put the electrons as far apart as possible, so you have 1 here and 2 here. The 2 still need to be in pairs, so you're going to put 2 together and then 1 as far away from it as you can on the other side of the third electron shell. And this is the completed model of aluminum. Our next example is phosphorus, and we're going to draw the nucleus and look at the periodic table to find out the number of protons, and we know that's 15 from its atomic number. And when we subtract its mass number from its atomic number, we find out that phosphorus has 15 neutrons. Now we're going to start drawing the electron shells. 2 can be placed in the first shell, and 8 can be placed in the second shell. Now let's think about how many more electrons we need. So if we have 8 in the second and 2 in the first, we have 10, and we still need 5 more to make a total of 15. So we're going to draw a third shell and place 5 more electrons. And be careful of how you do your electron pairing in the third shell here. You want to make as many pairs as possible as spread out from each other as you can. So we're going to put 2 electrons here, 2 there, and 1 more. In this case, I'm not going to mark you off if you put the electron pairs here, here, and here. I know it may be better to put them in this area, but I won't mark you off for it if you do that. For my final example is nitrogen. We're going to draw the nucleus and look at the periodic table, which tells us that its atomic number indicates it has 7 protons. And when we subtract the mass number from the atomic number, we do 14 minus 7, and we figure out that nitrogen has 7 neutrons. Now that we've figured out what's in the nucleus, we're going to start drawing the first electron shell, which has 2 electrons, and it can only hold 2. Next, we're going to draw the second shell, but before we start placing the electrons, I want you to think about how many more electrons need to be in the model. So if we have 2 in the first, and we need 7, that means we need to put 5 more electrons in this model. So we're going to start placing them like this. And like I said earlier, I'm not going to mark you off if you put the electron groups here instead of here. It's okay. I'm not going to mark you off for that. This is actually the completed model of nitrogen. And I hope you guys gained something out of this. I hope this made sense to you and you learned about how to create Bohr models of different atoms. Thank you for watching my video.